All right, this is another video on working with fractions. This is part 2. We're going to be multiplying and dividing. The big difference between multiplying and dividing, other than the obvious, is that there is no need to get a common denominator. And there are two ways that we can go about doing it. In this first problem, there's really only one way. But again, there's no need for the denominators to be the same. All we're going to do is multiply the top numbers. So it's 3 times 7, which is 21. And it's 8 times 11, which is 88. And that number is already reduced, so it is my answer. I don't need the decimal for that. I just want the fraction. So top times top, bottom times bottom. Let's try this here. So if I did negative 2 times positive 9, well, the number part is 18, and the sign is negative because there's one negative in that multiplication. And then the bottom number, the denominator, is 5 times 4, which is 20. And I noticed that these two numbers have a common factor of 2. So if I divide the top by 2 and I divide the bottom by 2, I will get negative 9 over 10 as my final answer. An alternate way of doing this is to recognize that when I take the fraction 2/5 and I multiply by 9/4, I could actually write it in any order I want. I could do 2 times 9 over 5 times 4, okay, which is essentially what I did up top, but I can then switch the numbers around because multiplication is called, it's a commutative property. I can switch the 5 and the 4, and then I could reduce the 2 and the 4 by the 2, and by doing so, it saves me a step later on. So now I'm multiplying the top and multiplying the bottom, and I get the same answer, except I did the reducing along the way, which is my preference, especially when we start to deal with bigger numbers. Now, this is not a tough one to reduce, but sometimes people struggle with recognizing what the common factor is, and it's easier to do when you have the smaller numbers. What do we do if we have mixed numbers like these? Well, it's the same first step. You need to get them into improper fractions, so we're going to multiply the 3 times the 11, that's 33, and I'm going to add the numerator of 7, that's 40, and keep the denominator. The next one, I'm going to multiply the denominator times the whole part, so that's 4 times 3 is 12. I'm going to add the numerator to get 13 and keep the 3. That looks like a B, so I'm going to fix that. Now, I'm looking for a common factor here and here, or here and here, or here and here. Any common factors? Well, 11 and 13 are prime, so those aren't going to reduce with anything. And 40 is not divisible by 3, so there's no need to reduce here. I'm going to multiply the bottom times the bottom, so 11 times 3 is 33. And I'm going to multiply by 40 by 13, which I'll do off to the side here. 40 times 13, that's 12, 400, add them together, 520. And I already know that doesn't get reduced, so there's my answer, 520 over 33. It might seem like a terrible number, but guess what? We're done. That's the answer to that problem. And that covers a lot of the multiplication problems that you're going to run into with fractions. So let's visit a division problem. So when we divide fractions, we're actually going to do multiplication by the reciprocal. So I'm going to flip the 5 and the 4. That's step 1, and the rest is just like the previous problems. Nothing reduces. I'm going to multiply the top, 3 times 5, which is 15. I'm going to multiply the bottom, 7 times 4, which is 28, and I'm done. That's it. So if you have a division problem, get them to be improper fractions or proper fractions if they're mixed numbers, and then flip the second number. You don't flip the first one, you flip the second number and you change it to multiplication.